This video is to provide an overview of the QA testing recommendations for the Xera cone beam system. The scope of the recommended QA tests are basically to take 4 measurements across 2 different volumes. For reference, this procedure is also documented in the section 10.4 of the Xera user manual. ImageWorks can also provide a test record sheet that can be used for internal purposes to keep records of the QA testing performed. The items needed to perform the QA test are located in the black case that was provided with the unit. Inside this case, there are 3 components that will be needed. First is the large chin rest platform, second is the small thumb nut, and third is one of the acrylic cylindrical phantom. You'll notice that there are 2 inside the case. The one that we'll need for this QA is the one with the slanted plane through the cylinder. To prepare the phantom, we just want to attach the cylinder to that chin rest plate. To do this, you'll notice on the bottom of the cylinder there are 2 holes. One is threaded and one is not. You actually want to fit the non-threaded hole over the little tab on top of the chin rest, and then align the threaded hole with the hole in the base plate, and then feed the thumb screw through to tighten everything together. Then you just want to slide the 2 pins of this assembly into the holes in the chin rest. Now you're ready to perform the QA, so you want to start by just taking a large field of view scan of that phantom. The resulting volume should look something like this. The first measurement is just the distance between the steel balls. To take this measurement, you want to migrate in the axial plane of the software to find the 2 steel balls at either end of the circle in the axial view. Move to this plane so that you can see these 2 steel balls, and then go to the measurement tool by clicking on the micrometer and simply clicking on both balls to measure the point-to-point distance. This measurement should be within the range specified in the manual. The next measurement is the disc thickness. For the next measurement, you want to migrate in the axial view down so that the horizontal line is about 2/3 of the way down in that axial view. Then you want to double click to enlarge that axial view. Then if you hold the roller ball of your mouse down and drag the mouse up, you'll further zoom in on that view. The goal here is we just want to get a good view of that horizontal line. Then we want to take the measurement of the thickness of that line in 3 different locations along that line. Then the actual QA measurement is taking the average of those 3 measurements. The next measurement is the short axis of the pin diameter. To make this measurement, you go back into that axial view and scroll down until you see the oval in the bottom portion of that axial view. You may want to try to zoom in as well. You can zoom in again by pressing the roller ball on the mouse. And basically you just want to take the measurement tool and measure the short axis diameter, which would be about halfway through that oval that you see. The last measurement is just the standard deviation of the phantom. And the way this is measured is, again, in that axial view of the phantom. You may want to double click to enlarge to a full pane, and then you can also zoom in just to make it a little easier. Then what we want to do is we want to scroll down in the axial view all the way down below that oval, but above the very bottom of the phantom, and that's where we want to take our measurement. To take the measurement, you want to click on the rectangle of the measuring tool and then just simply scope out a rectangle in that axial view, usually just in the space towards the bottom of that axial view. And what we're looking for is a area that is right between 60 and 61 square millimeters. And then the actual reading is actually that standard deviation, which is the SDEV number for the rectangle that's between 60 and 61 square millimeters. So now that you have all those measurements for the large field of view, you would just simply go back, take a small field of view scan, and then repeat those same measurements, and then you're complete.